Where did the universe come from? What a loaded question. People from science backgrounds have sought to explain it over many centuries. Same goes with people of faith. In fact, the two groups are generally seen as being on polar opposites of the issue. Well, I'm Daniel Kuberek, and today I'll be joined by Dr. Sven Ostring, a man who has done extensive research on both viewpoints. And he'll guide us through to a conclusion that might change how we see the universe.
Welcome to Signs of the Times Radio.
It is my pleasure this week to have Dr. Sven Ostring with us in the studio for the first, or actually it's going to be the second podcast of the year. How are you, Sven? How was your break over the New Year's, Christmas? How was it?
Yeah, it was really good. So we had just finished up at a rental place up in Newcastle here in Australia. So we had a few weeks kind of spare. And so I talked to my wife and we said, why don't we go and visit family up in Brisbane? And we did that for about 5 weeks. So we had a lot of time with cousins, with the grandparents as well. And we did experience a snap lockdown in Brisbane, which was a bit wild for the time, but we were a bit concerned, like, would we get back to New South Wales? But God was really good, and it all kind of dissipated in a way, and we were able to get back in time, and we were able to buy we're buying a house. So we picked up the keys.
Oh, congratulations.
Yeah, thank you so much. Got to move in, and it was just a really amazing opportunity that we had. So great time away with family, but it's been good to get back into the work that God has given me as well.
Yeah, absolutely. Yeah, exciting year ahead for you guys from the sound of it. And of course, again, congratulations for buying a house and the fact that you were able to successfully have your holidays despite COVID.
Yes.
Now, Sven, we love getting you on Science Radio, and we also love getting you on our magazine because there's some hard topics that we sometimes have in our magazine, and you're our go-to guy for answering those. Now, this article that you wrote for us late last year that was published in this month's January and February edition of the magazine is probably one of the hardest you've had to write, not just because it's a hard topic, but because you've had 1,200 words to do it. And that is, where did the universe come from? Now, before we dive into answering that question, I just want the audience to sort of like get to know a little bit of your background.
I've always had a real love for science. I love the topic. I love cosmology as well, because cosmology is this. It's a big topic. It's a big vision. I mean, it doesn't get. The only thing bigger than the universe, if I could put it this way, is God Himself. So to study the universe it's a dream for me because it's such a big, exciting area to look at.
When did your personal stake in this exact question, where did the universe come from, when did it start? Is this a topic that you started pursuing yourself as far as the scientific evidence for it at some point, or is it something that you've come across in your research? Like, when have you started to look at this particular one?
I guess it kind of goes back to an experience I had with my father. He was a great dad in terms of really giving me the opportunity to explore different ideas. So I remember one time he took me to a presenter, a speaker in Christchurch in New Zealand, who had been kicked out of the Uniting Church as a heretic. And the speaker no longer believed in the virgin birth of Jesus, no longer believed in the miracles and the resurrection. You know, he'd really gutted Christianity or the Bible of miracles. And I remember my mother saying to my dad, why are you taking Sven to hear this? And my dad said, well, it's good for him to know. You know, he should think about these things and understand. Otherwise, we're sort of protecting him. So I guess what happened was that he would take me to creation presentations where they explore the challenge of, the starlight travel time problem. How could an entire universe, which is so big, how could the light reach us? Which is a very important question, even for the Big Bang. Let me say that. But then, a few years later, he'd give me the book A Brief History of Time by Stephen Hawking, which is all about the Big Bang Theory and cosmological models. And so he really encouraged me to think about what does it mean to be a thinking believer in the Bible and Christianity. And so that is where it really started from, and I started to dive into information theory and how that can help us with understanding whether God exists. But certainly coming back to my landlady in Cambridge, when she started to ask questions, asked, where is the evidence that God exists? Then I started studying it kind of for real. I really got deep because I'd been challenged and I wanted to know as well. And at that time, I started to go into the Kalam cosmological argument. And that's just, you just dive deeper and deeper, drill deeper and deeper, and until you come to the reality, the metaphysical reality that God exists. It's an amazing journey. So
it's incredible hearing about how open-minded your parents are, because I think that really ties back to how you wrote this article. You kind of have to approach it from without presuppositions from one or the other side. But in order to just introduce our audience to what some of those concepts are, because you mentioned the Big Bang there. So
Yes.
sort of what are the predominant theories about how the universe began? And can you just give us a short sketch of what each of those, what the explanation is?
yeah. So if we go back in time, so let's go back in history.
Yeah.
For most people, they just looked out at the universe and every night it was the same. Mm-hmm. The stars came up, they of course they moved. That was really obvious. But there was just this sense, well, we live in this big home and it's always been here. We've never had to move home, put it that way. And so for the ancients, if I could put it that way, they saw the universe as being eternal. So you had the Babylonians, you had the Egyptians, you had the Greeks as well, Aristotle. He believed in a geocentric universe, so everything went round us. But beyond that, the universe was eternal. So that the universe always being here, being eternal, was, I guess, the stock standard understanding of the universe. It was the cosmology of the ancient Greeks and Egyptians and Babylonians. And indeed, for most scientists, they also accepted it as well. What happened was this, is that Albert Einstein, the great physicist in the 20th century, he was working on his theories of relativity. And so he had these models of gravity and he had his theory of relativity and started to put it together to model the universe. And so what he did, when he did that, he suddenly found that the universe could change its shape and size. So it could become bigger, effectively. And this really annoyed him because he, like everyone else, he wanted the universe to be eternal, to be kind of static in a way, not changing over time. So he actually introduced a constant into his equations to keep it steady, shall I say. But then later on, he realized that was a mistake. It's a famous statement. He says it was, the greatest blunder in his life.
Right.
So then we had a number of other scientists that came along, and you had these two cosmologists in the 20th century, Alexander Friedman and also George Lemaitre. And they took Einstein's model, which allowed the universe to change shape and expand over time. And they said, well, let's follow it back all the way. Just trace back the size of the universe.
Right.
And what they found was that the whole universe, as you go back, you wind the tape back, came to the point where the whole universe disappeared into a point and vanished.
All right. And that's called a singularity?
That's called a singularity, exactly.
Right.
And that is the Big Bang. That is the Big Bang theory, that the whole universe is expanding from a point at which it vanishes into in the past.
So the singularity exploded, and then that's how matter came about. Is that correct?
It's correct. Now, there's something we need to kind of clear up, if I could put it that way, is that the Big Bang is actually a derogatory, it's a negative term. Fred Hoyle, who liked the steady state kind of model, he thought it was just ridiculous. this idea that Lemaitre and Friedman and obviously Einstein had come up with. So he termed it, this is the Big Bang model. He said it on radio in England. But what the Big Bang model is, it's not an explosion into space. It's not not just a pallet going bang, and then suddenly we've got a universe. What it is actually space and time and matter expanding.
Right.
So it's not a pallet exploding into space. It's more like a balloon being blown up.
Oh, right. Okay.
That is the Big Bang model. So the Big Bang model says that the entire universe that we live in is basically stretching out, if we could put it that way. So that's the Big Bang theory. Now, that's one model of the universe. But of course, one of the challenges is it clearly points to the fact that the universe had a beginning. That the universe, if you play the tape of the universe back in time, it comes to a point where the universe just simply did not exist. It goes back to that singularity where which is incredibly hot, high temperatures, and then the energy starts to get converted into matter. That's the E equals mc squared equation.
Famous equation, right?
Exactly, Einstein. Yeah. So we take the energy, the really hot energy, and we start to convert that into matter over time. That is one model. Now, scientists, they love Einstein. Mm-hmm. They love the Big Bang theory. The problem is they don't like the singularity in terms of they don't like this idea that the universe could have actually, that it disappears into nothing effectively. Mm. So there's a number of different models that we could look at. There's so many. It's an exciting kind of area to look at. One of the things that people have said, for example, Lawrence Krauss, when coming to this question, because of course, the big question that follows from that is, how did the universe come into existence? If it goes back to a singularity in terms of for the Big Bang model, why did it come into existence? Mm. What is the cause?
What happened before the singularity
was
formed, right?
Yeah. What caused that singularity to come into existence and then expand to the universe in which we exist today? So there have been a number of people, including Lawrence Krauss and also Stephen Hawking himself, who've made the claim that says that the universe itself can come into existence from nothing.
Okay.
So Lawrence Krauss has a book, A Universe from Nothing, why something exists rather than nothing. And what he will say is that nothing can actually turn into something, which is pretty mind-bending kind of stuff, really, when you think about it.
Is that a problematic statement, that you can go into a car park one day, come back years later, and out of nothing there's a car there?
Well, it is a very big problem because of this, that we don't normally see that occurring. So exactly what you said. So when you're walking in the car park to go to Coles or Woolworths, you don't just see an F-35 fighter jet suddenly, boom, is right in front of you. You don't see a cheetah or an Amazon fighting ship or whatever it may be. This just doesn't happen. It's not part of our experience. So the question would be, if we don't see it in a small scale, why would we see it at a big scale with the entire universe?
Yeah.
So it challenges logic and our metaphysical experience of reality. So from our own experience, we'd have to say that it doesn't make sense that the universe would come from nothing. Mm. For our listeners who are old enough and who remember The Sound of Music, Maria sings song, Nothing Comes From Nothing, Nothing Ever Will.
Yeah.
And from our own just intuition, that is true.
Yeah.
That is true. But there's another really big problem, and that is this, is that when Lawrence Krauss talks about nothing, it is not actually nothing. Because what he's talking about is what we call a quantum vacuum.
Right.
So a vacuum is where you have sucked all of the air out of something. It's you've taken all of the matter out of that container. So for example, if we sucked all of the air out of this studio, then this would be a vacuum.
Right.
So normally you and I would think, okay, well, this is nothing.
And the vacuum is not made out of matter.
No, it's not. It's not. But this is the point. It's not actually nothing. From a physics point of view, that vacuum does have what we call a structure.
Okay.
There are physical fields, and it's a fluctuating field inside in terms of electromagnetics and energy.
Is this what you call the string theory, or is that something else?
That we're coming to that.
Okay.
We're coming to that. So what happens is that in a vacuum, so a vacuum also has a size and a structure as well, which means that it's not actually nothing. That's the key point that we need to remember here. So Lawrence Krauss is actually selling us a false idea.
Right.
He is making something sound like it's nothing when it's not actually nothing.
Okay.
Which is really important. So that's really important. So we haven't solved the issue of where the universe came from just by saying it can come from nothing. So we can then go on to from the vacuum. What can happen in physics is that these small particles just pop into existence. So with that E equal mc squared, you can go from energy, which is inside a vacuum, and it can fluctuate into a particle and then back again. Okay. And there's these ideas, well, what about whole universe? Couldn't we have a whole universe just appearing from this vacuum? The problem with that is that what those little bubble universes will do is they'll start to bump into each other and they'll start to merge. And over time they'll merge more and more to the point where you'll get a very vast, very old universe. But that's not what we see. We only see from a cosmological point of view, a fairly young universe. So there's a major problem. But even deeper than that, you have to ask the question, where did the quantum vacuum come from? And that's a fundamental question. So is
that something that scientists have been able to answer?
No, they haven't. They were just. It's kind of like they just start with that, but they can't explain where the quantum vacuum came from. So there's always this, you take it back one step, but the science can't go behind the final step.
It sounds like, Sven, like it's similar to evolution in a way. It's like the hunt for the missing link a lot of the time.
Yes.
Is that a fair comment? Like, for example, another thing I read about, which was where do the laws of physics come from? The Big Bang Theory, apparently,
yes.
Like, correct me if I'm wrong, says that it happened at some point very soon right after the singularity expanded. But they don't know why. Or they don't know why, they don't know how exactly. It's almost like there's so many unanswered questions to do with this, isn't there?
That's right. Because we need the laws of physics to actually govern the entire structure of the universe at a very fundamental level. It's kind of like trying to pull yourself up by your bootstraps idea, is that you need to describe the universe. You need these laws of physics. So the laws of physics cannot explain where the laws of physics came from.
That's such an interesting point.
Someone, another cause must have made the laws of physics. And this is a really important point that you're making here.
Yeah.
And you see a lot of design, a lot of intelligence in the laws of physics that actually govern the universe. I should also point out as well that, we're talking about the Big Bang Theory.
Right.
But some of our listeners might be under the assumption that I actually believe the Big Bang, which is not actually true. So I just wanted to clarify that. Now that's a whole topic in and of itself, but I just wanted to point out that the Big Bang Theory itself has a number of major problems in it. Not only where did the singularity come from, what caused the Big Bang, but there's a number of things. But in particular, one which is of real interest is that there's a problem called the horizon problem, which is effectively the same starlight travel time problem which we experience in other areas, such as, if the universe was very young, how did light travel all the way across the universe to here? So that's another kind of area. But I just wanted to point that out, that even as we're talking about the Big Bang, we need to recognize that there are major problems and reasons to actually reject it as well.
Because the Big Bang Theory, if we're going down that line, suggests that the universe is 13.8 billion years old, right?
That's correct, yes.
Yeah. Which is not young at all.
It's not young in terms of compared to you and our age.
Yeah.
But from a cosmological point of view, it's actually very, very young.
Okay.
Let me explain what the horizon problem is. Is that we look at the observable universe,
right,
and we can see 46 billion light years in one direction, and we can see 46 billion light years in the other direction. It's kind of like we're in this sphere. So that's kind of what we call a radius. But the problem is that we know that we exist within a universe at least that size. It could be even bigger. It could be way bigger. But if the universe is only 13.8 billion years old, how did light from 46 billion light years away actually reach us? And that's a major problem. There's also the problem with the background microwave radiation as well. And that's fairly uniform. But these are big things. But it's just to keep in mind that the Big Bang Theory as well, even though it has shown us some very interesting things, it still has major problems, and there's reasons not to accept the Big Bang Theory. There's other better explanations.
Okay, so what's one of those that you find as a better alternative for the Big Bang Theory?
Well, I guess for me, the key is that in all of science and in cosmology, there is what we call a rule, which is called methodological naturalism,
right?
Which means that science should never appeal to a miracle and a direct act of God as an explanation.
Okay.
So that's a rule. So if you go to any science conference, or you read a PhD in science, or you ask, you download an academic paper, one of the things you'll never find as you go through is that, halfway through they write, this is when God did a miracle for my petri dish or in my physics experiment.
Right.
They'll never do it. You're literally, the editors of a journal will send back your paper and say, you need to redo this. There's a very funny cartoon, actually, where there was a young scientist who does a whole lot of equations, and he calls in his supervisor. And so the cartoon, the old professor's looking at it, and right in the middle there, the young scientist says, then a miracle occurs. And the cartoon, the professor goes up and says, I think you need to do a bit more work here at this point. What it's saying is that miracles are not part of the language or the tools of science. But the point is that doesn't mean to say that it didn't actually happen, that God didn't work a miracle.
It sounds like there's a presupposition in place that doesn't allow for investigation of this.
Yes, exactly. And so there's a kind of blocking off of the supernatural and the miraculous.
Right.
Which is a very important thing to understand. Now, of course, that's not necessarily entirely bad, because if you want to study how the universe works normally in a regular kind of fashion, then that's a good way to go.
Yeah.
But the problem is, just by assuming that God hasn't worked a miracle and that he hasn't directly intervened, doesn't mean to say that he hasn't actually done it.
Right.
He could have. And that's a really important point. So when we look at the explanations for where the universe came from, one of the key things is whether we look at the Big Bang Theory or the quantum bubble universes, or if we look at string theory itself, and we can dive into that as well for our listeners. One of the things is that they all, as you go back in time, or the metaphysics, what you find is that we need a cause which is beyond the universe to be able to bring this universe into existence.
It's really interesting what you're suggesting here, Sven, because I've actually never thought about it this way. You're saying that this stuff could have happened this way, but that the cause of it all was not what science would usually suggest.
That's right, yes.
That's very interesting, because I always had this idea in my mind that they are so fundamentally at odds with each other that there's no possible way that those two explanations are on polar opposites. But you're saying that they might be more similar, but there's missing pieces in the Big Bang Theory that God can explain. Is that true?
Yeah, for sure, for sure. For example, the laws of physics. God can explain the laws of physics. He was the one that designed the laws of physics, actually brought it into being. Yeah, definitely. So certainly we can look at these things and we can say, yes, God can be the explanation for what we find in science. However, I think it is really important to keep in mind that just because science has come up with this model, that it's not necessarily true. There are other models which could be true. And for me in particular, I would say that I would go back and look at it and study the Bible. And I'd say, okay, well, the Bible is what teaches truth. Now, that's a very Christian position, but that's what the Bible says. That's what it stands for. And when we look at the Bible, when we study the Bible, and if we find that something in science affirms it and corroborates it with it, then we can say, yes, we're on solid ground.
Right.
But outside of that, science can be quite speculative. It's quite provisional as well.
Right.
So certainly we can see God's hand in it, but we need to be willing to continue to learn, particularly in the area of science.
And it's more than just, there are things that science can't explain. Let's plug an explanation of God into the gaps. It's about more than that. It's about looking at the evidence of, wait, what do we know about God already?
That's correct.
So what are the explanations, what are the pieces of evidence that you've come across where God would explain the creation of matter?
Okay, so certainly the fact that the universe has not always been here is a powerful pointer towards God being the cause, the foundational cause of the universe.
Right.
And so we don't necessarily need to go to the Big Bang Theory. We can go to other pathways to understand that. In particular, the second law of thermodynamics. And what that says is the second law of thermodynamics looks at a system like the universe and says, has it wound down to where everything is just kind of fundamentally all the particles are evenly spread out? No, it hasn't. So that the sun is still shining, we still get up in the morning, things are still happening.
Right.
So what that means is that there was the universe has only been here for a finite amount of time in terms of it has a short history or recent history, but it hasn't been here for all eternity. So that points us towards the fact that it had a beginning. It's somebody kind of wound it up, shall I say?
Right.
Like a clock.
Yep.
And that points us back towards the existence of God. This is really, really important. The second thing about the universe, and this is another major area, is that cosmologists have discovered that the universe is finely tuned for not only intelligent life to exist, but also for things like stars and galaxies to exist. And that's all these physical laws that we were talking about. What we find is that there's numbers or what we call constants in these, like the gravitational constant, which has a very specific number, so many decimal points. It's not a number that you'd expect.
Right.
So why is the universe finely tuned? If those numbers were different, if the gravitational constant was higher, then everything would just clump together and we wouldn't have galaxies and stars and planets. If the gravitational constant was lower, then everything would fly apart. So it's like we're walking along a knife's edge, and it's an incredible, sort of balance of all these constants. And what this points us to is the fact that an intelligent mind actually chose to have those particular constants for a reason, which ultimately is that intelligent life could exist and that you and I could be here in the studio and that people could be listening to us. So both the beginning of the universe as well as the fine-tuning of the universe are powerful indicators that God created this universe, that he is powerful enough to do it, that he's intelligent, he has the knowledge how to do it. Also, we can go back and recognize that God is an uncaused cause. He wasn't created. We need that from a logical point of view. Then not only is God an uncaused cause, but he also wanted you to exist. He made that choice. Mm-hmm. So he's a person as well. He's not just a physical law or a physical entity. He's a person who said, I want these two guys to exist, and I actually love them, and I want to be part of their lives as well. It's an amazing journey where you can go from the very beginning of the universe and discover a God who really cares about us and wants to be with us forever.
Now, Sven, that's a very interesting point you make, because for someone who's always looking for the next piece of evidence to explain a certain thing, and then the next one, and then the next one, it's like an endless pursuit of an answer that may not come in one's lifetime and then wouldn't come in the lifetime afterwards for someone else. At some point, you're suggesting that one has to take a leap of faith and accept that there are things that we can't explain through science, and that would be explained by a God. Is that correct?
So what faith is faith is taking the evidence that we have and saying, what is the best, most rational explanation for it?
Yeah.
Faith is also the concept of trusting as well, and that comes to a personal thing, but we'll come to that in a moment. But the point is this: we can take all the evidence that we have from cosmology and physics, and all of the evidence points towards the existence of God.
Right.
So we can confidently say, okay, that points towards the existence of God. Follow the evidence where it leads.
Right.
And go with it. And I think there's an important point that you're making here, which is sometimes we have to have the courage to step out, to move forward, to be willing to. It's not a step in the dark. It's not a leap in the dark. It's about saying, I'm going to just sit down and reflect on it, and I'm going to make that choice. And when the evidence points towards the existence of God, I'm going to say, yes, I'm going to accept it. I'm not going to try and keep shying away from it. I'm not going to keep trying to avoid that conclusion. And Robert Jastrow, an astronomer and astrophysicist, made a really interesting kind of analogy. He said, for cosmologists and astronomers, this whole question of the beginning of the universe is a bit like it's a bad kind of nightmare. Right. Because, you've been struggling up the mountain of all of this evidence, and then you climb to the top when you think, wow, we finally made it.
Yeah.
And when you finally, reach over the top, what you realize is that there's a bunch of theologians and people of faith who've been there all the time and said, it's God. It's God. But I think this is the point, is that there's times in our lives where we need to be willing to say, yes, I'm going to move forward. I'm going to follow the evidence. I'm going to come to a conclusion. I'm not necessarily going to fight the reality of what we find here. And that's a very important kind of conclusion that we need to have in life. And the other thing too is faith is not only taking the evidence and following it where it leads, but also faith is about trust.
Right.
Faith ultimately is saying, from a biblical point of view, it's about saying, I'm going to trust that the God who revealed himself as the creator of the universe, as we find in Genesis and Hebrews and Colossians, he did actually step into this world in a very special way. First of all, by revealing himself to people who wrote down, his messages in the Bible, but also in particular, as the book of Hebrews says, in the person of Jesus Christ.
Right.
And I'm going to trust him because of not only his power, not only his wisdom, not only his intelligence, but also his incredible love and willingness to sacrifice his own life for our eternity. And it's incredible. Incredible.
So you're saying, Sven, for someone who's listening to this, probably learnt about the Big Bang Theory in high school, probably saw the show on TV, and now they're listening to this and they're feeling challenged, like, hey, Sven's right here. There's big logical gaps, and maybe the Bible has an explanation for it. Where can we find some sort of scientific evidence for God in the Bible? Is it in the beginning, like the first book, I think Genesis? Is that a good place to start for this sort of thing?
Yeah, I would certainly recommend that you just start at the reading through the Bible, reading the book of Genesis. There you will find the biblical account of creation. And what I would encourage you as a listener to do is this. Read Genesis chapter 1 and 2 and ask yourself this question: what is God like?
Right.
What are these chapters in the Bible telling us about what God is like? Because God is the main character in Genesis 1 and 2. It's every sentence almost, and God did this, and God did this, and God did this. So what is the Bible actually telling us about God? So, you might have questions about science and cosmology and evolutionary biology, but let's put that aside for a moment and let's focus on the Bible is teaching us about God. And we'll come back later to how, you can integrate the Bible and science. But I'd not only start with Genesis chapter 1 and 2 and 3, and you can continue on in Genesis, I'd also invite you to go to the Gospel of John.
Right.
Because the Genesis starts with, in the beginning, God created the heavens and the earth. That's where Genesis starts. But John, a close friend of Jesus, starts his biography of Jesus in a very similar way. He's intentionally drawing a parallel, and he says, in the beginning was the Word. And he is referring to Jesus.
Jesus is symbolized as the Word, right?
It's a name, a kind of a title.
Yeah.
It means that Jesus is God's way of expressing himself, communicating, revealing himself. And I would encourage you to go to the biography of John. It's about 3/4 of the way through the Bible. You've got Matthew, Mark, Luke, and John.
Yep.
So if you go 75% through, you'll find it there. And start to read about the life of Jesus. And same question: what is God like? Who is God like? And just go through the life of Jesus. And what I will tell you is that you'll be absolutely amazed and blown away. You'll be amazed at how Jesus can handle conflict, how he loves people who are blind and physically challenged, that his insights are so clear and accurate, that he doesn't have this, narcissistic kind of personality. He's just really direct, but his incredible thoughtfulness and kindness towards people is amazing. And I would encourage you, and what you'll find is that there's a picture of God that has attracted people for 2,000 years. And that when you come to know Jesus, and that he can turn water into wine in an instant, that he can cause a man who is blind to see in a moment, in a twinkling of an eye, as we might say.
Right.
Then suddenly you realize there is a God who can perform amazing miracles. And that will change your life. And that you could even ask the cause of the universe, the person that created this entire universe, 93 billion light years across from what we can see, and with billions of stars and galaxies, you can call upon him, and he will listen to you, and he will work a miracle in your life. And so you can not only be exploring the evidence for God in the Big Bang and the laws of physics, but you can actually experience your own experience of your own evidence, I should say, of God's reality and his love and his power as well. And that's what I would encourage you as a listener to do.
Wow, what a powerful challenge. The fact that someone or an entity that is capable of something like this can be so personally connected to a person. That's an incredible encouragement to reach out to God, really. And
Yes.
also to assess this for ourselves, assess the evidence, try God, see what he's really like.
That's right. That's right.
Well, it's been a great, I think it's more than half an hour now with you, Sven. I really appreciate tapping into your insight. I mean, stacks of more questions I could have asked you, which is probably why we're going to definitely get you on to the podcast again in the future to talk again. But I really appreciate that you came in to talk to us, Sven, and share your insight and explain your reasons for a creator God, as well as explaining what the Big Bang Theory is all about. So I really appreciate that you came in to talk to us. Thank you, Sven, for joining us on Science Radio this week.
No problem. Look forward to being back.
Today's episode was based on an article appearing in this month's Signs of the Times magazine. A subscription is just $26 for 11 issues a year. To find out more, visit signsofthetimes.org.au in Australia or signsofthetimes.org.nz in New Zealand.
This is an Adventist Media podcast.